Okay, welcome back, students. We're going to go over section 1.4, trigonometric identities and the definition of trigonometric functions. We have reciprocal identities for all angles theta for which both functions are defined. The following identities hold. The sine of theta is 1 over cosecant. The cosine is 1 over secant. The tangent is 1 over cotangent. The cosecant of theta is 1 over sine. The secant of theta is 1 over cosine. And the cotangent of theta is 1 over tangent. Exercise 13 says, find secant given that cosine is equal to -2 over radical 20. So they're saying that we want to find secant. Well, secant of theta is 1 over cosine of theta. And so that's 1 over -2 over radical 20. Now, when I divide a number by a fraction, I really multiply by its reciprocal. So this becomes 1 times radical 20 over -2, which is just radical 20 over -2. And I can simplify that if I want to. I could make it into, I can pull out a radical 4 here. So that's 2 radical 5 over -2. And so this just becomes negative radical 5 at the very end. And that's the secant. Okay. Okay, the signs of trigonometric values. I'm just going to talk about sine, cosine, and tangent, but cosecant, secant, and cotangent, they follow the same pattern as their counterparts. Okay, so if you know sine, cosine, and tangent sine values, then you know cosecant, secant, and cotangent because they're just partners with their counterparts, their reciprocals. Okay, so in the first quadrant, quadrant number 1, we call this, the sine of theta is positive. The cosine, I'm not going to use theta. Theta is assumed. The cosine is positive and the tangent is positive, and the reciprocal identities are also all positive as well. Okay, in quadrant 2, the sine value, which is the y value, that's still positive. Okay, but the cosine is now negative. And since tangent is the y over the x, okay, or sine over cosine, we get one negative there thrown in. And so the tangent ends up going negative. So tangent is negative. Okay, in the third quadrant, quadrant 3, we have a y value that's negative and an x value that's negative. So sine is negative and cosine is negative. And then if we were to do y over x or sine over cosine, that's going to be negative over negative, which is going to turn the tangent positive. And in quadrant 4, we get the sine, which is the y value, is negative. The cosine, which is the x value, is positive. And the tangent is negative because there's one negative and one positive. Okay. Okay, the ranges of the functions of the 6 trig functions. The sine of theta, the range is -1 to 1. That's the output values. The cosine output values are also between -1 and 1. They're bounded. The tangent and cotangent, they go from negative infinity to positive infinity. And the secant and cosecant, they go from negative infinity to -1. And then there's a jump. There's a jump from -1 to 1. Okay, and then 1 to infinity. And when we talk more about the graphs of these things, you'll begin to see why the range is what they are. Okay, example 14, determine the signs of the trigonometric functions of theta is equal to -290. So I'm going to find my coterminal angle here to figure out, well, which quadrant is this actually in? I don't want a negative angle, I really want a positive one. So I'm going to add 360 to this. If I add 360, I get 50 degrees. Oh, okay. So if I get 50 degrees, that's in quadrant 1, where everything is positive. So the sine of 50 degrees is positive. The cosine of 50 degrees is positive. The tangent of 50 degrees is positive. The cosecant of 50 degrees is positive. The secant of 50 degrees is positive. Oops. Is positive, and the cotangent of 50 degrees is positive. Okay, example 15. Determine whether the statement cosecant equals 0 is possible. So is this possible? Well, let's think about this for a second. The cosecant, okay, that was based on the y. This is r over y from our previous section. It's also 1 over sine, okay? So the only way that I could get the cosecant of theta to be 0 would be to make the sine 0, because it's 1 over the sine value. However, if I let the sine be 0, then this is not 0. It's actually undefined. And so there's actually no way to get this to be 0. The only way to get cosecant to be 0 is if we let the r be 0, in which case we don't really have anything. We don't have a trig function, because if the radius is 0, if r is 0, then we just have a point, and it's called the origin. That's it. And we don't have an angle. We don't have a triangle. There's no triangle. Okay, no triangle. Okay, so is this possible? No, not possible. Okay, example number 16. Find the sine of theta and cosine theta given theta in quadrant 3 and tangent is 8 over 5. Okay, so we're saying that theta is in quadrant 3. So what does that mean? It means that it's over here somewhere in quadrant 3. What does it tell me about the x and y values? Well, the x value is going to be negative and the y value is going to be negative. That's the value of, that's the nature of quadrant 3. So if the tangent of theta is y over x, and it's a positive value, but everything's in quadrant 3, this tells me that I would have had a negative y over a negative x, okay? Which means that I would have had a negative 8 over negative 5. So just make sure you understand that the tangent of theta is positive in quadrant 3 up here. Okay, so here's quadrant 3, and yes, the tangent is positive, but the sine and cosine are both negative. The x and the y value are both negative. So if I want to find sine, okay, then the sine of theta is equal to y over r. Okay, so then what's r in this case? Well, r again is the square root of x squared plus y squared. So r is equal to the square root of x is going to be negative 8 and y, or sorry, x is negative 5. Negative 5 and y is negative 8. So we have negative 5 squared plus negative 8 squared. So r is equal to 25 plus 64, which ends up being 89. So r is equal to the square root of 89. Okay, and so the sine is going to be y, which is negative 8 over the square root of 89. And then I can rationalize that denominator if I want. So this becomes negative 8 radical 89 over 89, and that does not reduce. So we get that as our sine value. And then cosine is just going to be x over r, which is going to be -5 over radical 89, which is going to be equal to -5 radical 89 over 89 when we rationalize that denominator. Okay. Okay, let's do our last example here. Find cosine and tangent given that this is the sine value. Okay, so the sine is going to be -2 radical 3. Let's look at the Pythagorean identities here. Okay, so the Pythagorean identity said that the sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared theta. Okay. 1 plus cotangent squared theta is equal to cosecant squared theta. Okay, and then the sine over cosine, that's the tangent. Tangent is sine over cosine. Okay, and the cotangent is cosine over sine. So if we're given the sine of theta and we want to find the cosine of theta, I could use this guy here to help me do that. So let's use that guy that relates sine and cosine. So the sine of theta squared plus the cosine of theta squared, and then this sine squared theta, that really just means sine of theta squared. Okay, it's just a different way of writing this. Don't make the mistake that you're squaring the whole thing. Okay, it's the sine of theta and then you square it. So if the sine of theta was a negative value, then you would have to square that negative value to end up with a positive value, which is what we're going to be doing here in a second. So sine squared theta plus cosine squared theta is equal to 1. So this is going to become negative radical 2 over 3 squared plus cosine squared theta is equal to 1. So this is going to become the negative times a negative, that's a positive. The radical 2 times radical 2, that's radical 4, which is just 2 over 3 times 3, which is 9. So when I square that out, I get 2/9 plus cosine squared theta is equal to 1. Okay, so let's take the cosine squared theta and let's subtract off the 2/9 from both sides. 1 minus 2/9, which is 7/9. And now what I'm going to do is I'm going to take the square root of both sides here. Okay, I would have a plus or minus. However, they are telling me that cosine has to be a positive number. That's what that is there. So we know that cosine has to be a positive number, so we can drop that plus or minus because we don't need the minus. It's just going to end up being positive. So cosine theta is equal to the square root of 7 over the square root of 9, which is 3. So cosine theta is equal to square root of 7 over 3. Okay, now we want to find the sine of theta. I'm sorry, the tangent of theta. Well, the tangent of theta is just equal to the sine of theta over cosine of theta. And we know that we're given the sine of theta, and we know now what the cosine of theta is. So we just want to find the proportion of sine to cosine. And so we're going to get sine theta over cosine theta. Sine theta, they told us, was negative radical 2 over 3, all over cosine theta, which is radical 7 over 3. And then again, when I divide by a fraction, I multiply by the reciprocal. And so this equals negative radical 2 over 3 times 3 over radical 7. The 3's are going to cancel. And I'm left with negative radical 2 over radical 7. I can rationalize the denominator by multiplying by radical 7 over 7. And I get negative radical 2 times radical 7, that's negative radical 14 over radical 7 times radical 7, which is radical 49. And the square root of 49 is 7. So I get negative radical 14 over 7, and that's my tangent of theta. Okay. And that's section 1.4. And I'll see you guys in the next chapter.